Hello everybody, it's Jeff Hunt here, and this is part 4 of my mini series on the science of water, and today we're going to look at how water moves from one state to another and what it takes to move it. Well, it's tempting to imagine that a liquid evaporates to a gas when it gets hotter, but actually at the borderline of the liquid state and the gas state, the liquid changes into a gas at exactly the same temperature. So, for example, like a millimetre in one way, so to speak, you're in liquid state, and in a millimetre to the other side, you're in a gas state. So to change in state, it's not driven by the change in temperature, but by an intake of heat. So when it evaporates, the liquid soaks up heat without changing its temperature. This really sounds a bit odd because we usually imagine that heating entails an increased temperature. But during one of these phase transitions, well, that just isn't the case. So the substance alters its heat content and consequently the new arrangement of its particles without altering its temperature. And this is why when you keep boiling a pan of water on a hot plate, the temperature doesn't seem to increase any higher than 100 degrees C, despite the fact that you're applying more heat to the pan. The water absorbs the heat from the hot plate. The heat absorbed by a gas as it evaporates from a liquid is called the latent heat because it seems hidden, sort of unaccompanied by a rise in the temperature. So the gas takes a lot of the heat with it, which is why evaporation cools you down. Now if we look at this in reverse, latent heat is released again when the gas condenses into a liquid. A cold surface takes the latent heat from the gas and absorbs it. And that allows the water to condense. So it's like a hot plate in reverse. A hot plate heats a pan into the water, gets to 100 degrees, no more increase in temperature, and then the liquid flips to the gas. In reverse, when the gas comes into contact with a cold wall, that acts like a chill beam. It absorbs all the latent heat and dissipates it, which is why the gas can then return to the liquid state. So you can see that the warmer that the wall is, the less chance it has to absorb the latent heat, and so the risk of condensation reduces. So what does it take to move water in its different states? Well, the answer is actually quite a lot. And yet again, water has the highest heat capacity of all liquids because it can absorb huge amounts of energy before it changes temperature. So just to show you how much that is in comparison, it actually takes less energy to heat a brick by 1 degree than it does water. It takes about 4,200 joules to raise the temperature of 1 kilogram of water 1 degree C. And if you want that comparison again, compared to a brick only needs 840. So to convert ice to water takes even larger amounts of energy, and this is huge. You need 333,000 joules of energy, okay, to bring 1 kilogram of water from 0 degrees C to 4 degrees C where it melts. Okay, now if you were to put the same energy into the water from 4 degrees C, it would take it to 84 degrees centigrade. That's a huge amount. So because it takes a lot of energy to gain or lose temperature, it makes water very, very stable because it doesn't constantly fluctuate in temperatures. And as we are composed of about 70% of water, This is also the reason why our own body temperature doesn't fluctuate that much, and that we are basically in tune with the heating and cooling rates of water. It's why we use it for cooling and heating systems. It's plentiful, it's cheap, it's non-toxic, and it transports heat very, very efficiently. 1 kilogram of water can carry 6 times more heat than a kilogram of air, but it needs 800 times less space to do that. And it's easy to pump. You can't compress it, and you can move the heat better by using water than you can with air. Oceans cool slower than land due to the high heat capacity of water. This stabilises the climate of the planet and keeps us all safe and warm. So the latent heat capacity of water is immense, and this is one of the amazing bits of the science of water which we need to use every day. When we think about condensation in our work, we need to think about how water does it and how amazingly it does it and what it takes to do it. And let's not forget from the other series that we've seen is that water can be in 3 states at atmospheric pressure, and this makes it one of the most amazing chemicals that we've ever come across. And it's why we as surveyors really need to make sure that we keep on top of our knowledge of the science of water.